Okay. I had you guys watch a couple videos, and that was to set us up for oxidation reduction reactions. So before we talk about those reactions, I just want to put them in perspective with what we've learned already. So we did precipitation reactions, which, if you remember, the way we knew that it was a precipitation reaction is that you saw that solid form, but solid was formed from salts. So there might be some solids formed in other reactions, but the precipitation one was where we looked at the solubility table and then figured out a solid was formed. Acid-base neutralization is just what it says. It was when we had an acid, so something started with H, reacted with a base, which was something that ended in OH, and they neutralized each other to form. So the acid and the base came together. The H and the OH came together to make water and whatever the salt was. And it came out of the acid and the base parts. So that's what's in blue is like what happened in each one of those reactions. For oxidation reduction reactions, the thing that makes those characterized as oxidation reduction is that there's a transfer of electrons in between different atoms in the chemical reaction. So there's a part on Alex that you're going to see in the next Alex assignment where it talks about which atoms the electrons are getting transferred to and from. So in order to see this transfer of electrons, you have to be able to see what gained and lost the electrons. So let's do some vocabulary first. So the first word is oxidation. So this is put on that pre-quiz because this is essential for the wording of all these problems. So oxidation, so one atom has to gain electrons, one has to lose. That's the way that they transfer. So oxidation, that process is the loss of electrons. So then reduction is the gain of electrons. So one atom's losing, one atom's gaining. So a simple example of an oxidation process would be if you had sodium turn into sodium ion. So in order to get more positive, it had to lose something negative. So to go from the neutral sodium atom to Na plus, it lost an electron. If it lost an electron, this process that happened here is an oxidation process. And then you could have something like Cl, and I'll write it that way because chlorine's always the diatomic, turning in to 2 chloride ions. And again, this will be the oxidation states or numbers that you learn, but this is neutral. There's nothing here, it's just chlorine. And it goes to Cl minus. So this has a negative charge. This didn't have a charge. That has a negative charge because it gained electrons. We'll just put gain electron at the bottom. So that process is reduction. So something has to gain for something else to lose to make that transfer of electrons. In order to figure out what's gaining or losing, so you could answer what was oxidized or what was reduced, you have to be able to use that handout. So this is the handout. So I would have this open on your computer. If you have a printer, like print it out and have it next to you so that you could see when we go through these rules. And again, these are the rules that were on the video that I had you guys watch. And he kind of had them up on the screen the whole time when he was doing it. Had it very well organized. But I'm going to point to these as we do some of them because you have to be able to look at each one of these atoms, say what its oxidation number is and how that oxidation number changed to figure out if it gained or lost electrons. Did it go up or down in those oxidation numbers? So the first rule that's on there is if you have an element and it's by itself and there's no charge written up there, it's 0. So this only works if it's an element by itself. Down here it says Cl2, it's a diatomic, but it's still just that element. It's still just that element and there's no charge there. So that's 0. So those are two good examples of the first rule. So again, look at your rules for assigning oxidation numbers. The first one is an atom in its elemental form has ON oxidation number of 0. And then if we go down to number 3, so let's go down to oh, okay. So it's kind of 3, but the way it's worded is not so great, but this is an easier one. So if you have what we call the monoatomic ions, right? It's just one element and it has a charge on it. Whatever the charge is on that one element, that's the oxidation number. So like down here for Cl, there's 2 of them, but you don't care that there's 2 of them. You're just looking at that individual atom or ion and seeing that it has a -1 oxidation number because it has a -1 charge. So if you look at the blue, you can see that it went from 0 to -1. It can go down or get reduced if it gains electrons because it's gaining something negative. So because it's gaining something negative, it's going down. So you always have to think that when you're talking about the gain or loss of electrons, you're talking about something negative. So you're gaining something negative or losing something negative. So sodium goes from 0 to 1. So the only way it can go up in oxidation number is if it loses something negative. If it loses something negative, that's oxidation, and it lost a negative electron. So we have to know all those rules that are over here in order to be able to write them above each one of the individual atoms and then look at the reactant versus the product side and see how it changes. That's how you figure out what is oxidized, what's reduced, what the oxidizing agent and the reducing agent are. So let's do a couple more examples and then we'll do an actual reaction. So let's do an example of rule number, let's do rule number 7. So rule number 7 is for oxygen. So oxygen is almost always -2. So let's say usually -2, but of course we've got an exception. So the exceptions are unless in a peroxide. So peroxide is that polyatomic. So when you have a peroxide, there's 2 of them that are -2, so that oxidation number is -1. So it's not the same as a charge. Sometimes it's the same because the charge is the oxidation number, but you're really looking at what the oxidation number is on each one of those individual atoms. And then the other one that isn't on here, but I'm going to put up here just because it kind of explains something else, is unless it's paired up with fluorine. So the special thing about fluorine is it's the most electronegative element. And some of you put this as your, I think it was the oxidizing agent that you had on the pre-quiz that I gave. You used fluorine as an example because it's the most electronegative. So it always gets the electrons. So anytime something's with fluorine, fluorine gets -1. So if it's with fluorine, you're going to have some positive oxidation number for oxygen. So I'm not going to give that one, but I at least want to point out that it's not like what you're used to doing for ionic compounds. So oxygen is not just like the charge 2-. It depends on what it's with. But for all the problems I'm going to give you, maybe there's some exceptions in Alex they do, but for all the ones I'm going to give you, I'm always going to have you assign oxygen with a -2. So let's erase what's down here. So it's good to have those notes so that you know the difference, but now just to simplify the systematic process that we're going to go through, let's do the next rule. Let's do 9. Okay, rule number 9 is for hydrogen. What are we going to do for hydrogen? So if it's by itself, so if you just have H2 by itself, that follows rule 1, which means it's just neutral. If hydrogen's paired with something, so let's say hydrogen paired with another element. Okay, if it's paired with a metal, going to be -1. And if it's paired with nonmetal, +1. So an example would be if I put say I have lithium hydride. So it's paired with a metal, so the hydrogen gets -1 oxidation number. Paired with a nonmetal would be like so that's a nonmetal that is paired with. So that hydrogen in this compound gets +1. So hydrogen can be +1 or -1. It just depends on what it's with. What it really depends on is, and all of this depends on, is which one of these two elements is more electron drawing. Which one's going to pull the electrons to itself? That's the one that's going to have the negative charge. Like fluorine always pulls it to itself because it's the most electronegative on the periodic table. So that's hydrogen, oxygen. You have those simpler rules for if something was just an element by itself or it was an ion by itself. Other ones that are easy are rules 5 and 6. So that's like the charges. So rule 5 and 6 is if you have a group 1A, it's going to have +1. If you have a group 2A, it's +2. So those are similar to what the charges would be. And then the halogens, so rule 8. So usually -1, which is what we're used to with charges, unless it's paired with a more electronegative atom. So if you had a halogen like chlorine, so let's do an example down here. So if you had something like chlorine with fluorine, and say we just had one of each, so they can't both have negative, because the overall charge here is 0, so they have to balance each other out. So it's not like charges really, it's oxidation numbers. So the one that gets the negative is the most electronegative, and fluorine always gets a -1. So even though you're used to all the halogens being -1 because they're in 7A, when chlorine's bonded to fluorine, it has an oxidation number of +1. So let's do a couple examples, and then there's so many examples on the videos that I posted. So the first video is all these rules, and the second video is a lot of examples. So I would, after you do this, go back through and look at all those examples. So let me put up 3 different ones. So let me put up 3 different ones. Okay. So the easiest one out of these is this one. So when you have an element and it's by itself, its oxidation number is the first rule. So that's 0. So hydrogen just by itself is 0. If it was that, which is different, this is the hydrogen ion, the charge on that one is +1. So you can have an element by itself, no charge there, element by itself but has a charge, so the oxidation number is the same as the charge. When you have more than one element together, you have to know one of them to figure out the other one. So oxygen has the exceptions, but we're going to just not do any of the ones that are exceptions and say oxygen is -2. So what does carbon have to be to balance out that -2 on oxygen so that they cancel each other out? Because this doesn't have a charge written over here. So the carbon has to be +2 to balance out that -2 on the oxygen. So over here on the sulfur, same thing. You have -2 for the oxygen, but you have 2 of them. So this whole negative part is -4. So then the sulfur has to balance that out with a +4. But if we had, let's say I had one of our polyatomics. Let's do SO3 2-. So same process, -2 for oxygen itself. There's 3 of them. So let's put that here. Sulfur, we don't know what it is. But we know all of this needs to add together to be -2. All of these need to sum up to equal 0. But all of these need to sum up to equal -2. So you have this question mark plus the -6 from the oxygens equaling -2. So what would that sulfur have to be so that when added to -6 it's going to be -2? So that is 4. So that sulfur had to have had an oxidation number of 4. So that when you add it with the 3 -2s of the oxygen, you end up with -2. So the rest of the rules that I'm going to have you go through on the other video so that I can spend time actually doing the reaction. So in the next video, I had you guys watch a couple videos. And that was to set us up for oxidation reduction reactions. So before we talk about those reactions, I just want to put them in perspective with what we've learned already. So we did precipitation reaction.